Good morning, ma'am.
Good morning, ma'am.
Good morning. Okay, let us begin today's class. We'll have again cover some more examples on Fourier transform, sine transform, as well as cosine transform. So let us consider an example using Fourier sine integral. Show that integration from 0 to infinity 1 minus cos pi lambda divided by lambda into sin x lambda d lambda, it is equal to 1 by 2 pi for the interval 0 to pi, and it is 0 for x greater than pi. It is show that. So can you suggest me how to begin? What it tells? Already it is mentioned here that it is sine integral. That means transform. Okay. Now here it is some function, and one more thing is instead of s here, parameter s, here you are having the parameter lambda. Instead of s, you are having lambda. Okay. So with that, can you tell me how to go for it? How to begin? What will you consider LHS and RHS as? What will you write? Fourier transform of some function f of x. Fourier transform of a function f of s, whatever it is, whether it is cosine, sine, we'll write it as f of s usually, right? Now here, instead of the parameter s, we have the parameter lambda. So what we'll consider is f of lambda, given this is given to us. F of lambda is integration from 0 to infinity 1 minus cos pi lambda divided by lambda into sin x lambda d lambda. And what will be our RHS? This is Fourier transform of a function is given by f of s. So this LHS is our f of lambda. So RHS, it is f of x is equal to, we have the function 1 by 2 pi in the interval 0 to pi, and it is 0 for x greater than pi. So this is given to us. With this, we need to show the given relation. For that, since we know f of x, let us go for finding the applying Fourier sine transform, because it is mentioned sine integral, applying Fourier sine transform for f of x. Fourier sine transform for the function f of s, we have f of s is equal to, usually you will write, let me write the formula, later will change. Fs of s will write usually, it is equal to, what's the formula? What's the formula? Am I audible or not?
Yes, ma'am.
Then reply anybody. What is the formula for the Fourier sine transform?
0 to infinity f of x sin sx dx.
Yes. Integration from 0 to infinity f of x into sin sx dx. Right. So this is your formula for Fourier sine transform. Now let us substitute the function f of x here. Let us substitute the function f of x. For that function, how it is defined? In the interval 0 to pi, it is 1 by 2 pi, whereas for x greater than pi, it is 0. So we'll split this integral from 0 to pi and again from pi to infinity. So from 0 to pi, from 0 to pi, function is 1 by 2 pi, f of x 1 by 2 pi into we have sin sx dx. Okay, and from pi to infinity, value of the function is 0. Let us integrate this. 1 by 2 pi is constant. Integration of sin sx. What's the integration? Minus cos sx by s. Limits are from 0 to pi. Now, if you substitute the limits, keep minus outside. Let me keep minus outside. So what we have, cos, and even s also can be kept outside. We can keep constant minus, it is pi divided by 2 times s, cos s pi, then minus cos 0 it is. Now this can be written as pi divided by 2s 1 minus cos pi s. Okay, minus I have multiplied, this minus is multiplied inside, cos 0 value is 1. So minus of minus will get it as plus 1, it is written first. Now we have this value, but what is asked here? See, this 1 minus cos pi lambda divided by lambda, that is nothing but 1 minus cos pi s here divided by s. Again it is into, you have sin x lambda. How to get this? For that we need to go for the inverse Fourier sine transform. Again applying inverse Fourier sine transform. Once we have got this fs of s, apply inverse Fourier sine transform. Apply inverse Fourier sine transform. So what we have, f of x is equal to, applying inverse, formula is f of x is equal to, what it is? What's the constant term here? What's the constant to be multiplied outside the integral sign?
2 by pi.
Yes, 2 by pi. For Fourier transform, it is 1 by 2 pi. Sine and cosine will be multiplied by 2 by pi. Integration from 0 to infinity, f of s sin sx. So it is 2 by pi. Integration from 0 to infinity. Let us substitute the function f of s. It is pi divided by 2s into 1 minus cos pi s into we have sin sx ds. Okay. Now 2 cancels from from numerator and denominator. Even pi also cancels, right? Pi cancels. So what remains? We can see what the show that is there. What is your show that? Show that it is 1 minus cos pi lambda you have, and multiplied by sin x lambda. So no constant term is there. That's what we are left with here. So if you take this here, it is integration from 0 to infinity 1 minus cos pi s divided by s into we have sin sx ds. Now this is LHS, we have written f of x. So we just write the terms in proper manner. Let me write this first. Integration 0 to infinity 1 minus cos pi s divided by s into sin sx ds is equal to f of x. So what is f of x? It is already we have taken the function f of x is 1 by 2 pi for 0 less than x less than pi, and it is 0 for x greater than pi. Now just replace s by lambda because answer is given in terms of lambda. Replace s by lambda. Integration from 0 to infinity 1 minus cos pi lambda divided by lambda into we have sin x lambda d lambda. is equal to, we have the function 1 by 2 pi from 0 to pi, and it is 0 for x greater than pi. And that is our answer. Show that it is. So we have got that answer. Let us go for another example. Solve the integral equation. Solve the integral equation. Solve the integral equation. The equation given is integration from 0 to infinity f of x cos alpha x, it is cos alpha x dx is equal to e raised to minus alpha x. So the question is, solve the integral equation. Solve means what you have to do? What do you mean by solve this equation? Suppose the equation is x square minus 4 equal to 0, and if you are given solve this equation, what will you do?
Find the value of x.
Find the value of x. Now here solve the integral equation, that is. So which is unknown here?
F of x.
F of x. So you have to find f of x. Now how to get f of x? How to get f of x? You have to go
By
for,
inverse transform.
yes, by applying inverse, which transform? Which transform you have to apply? Fourier transform,
Sine
cosine
transform.
transform, y sine transform?
Cosine transform.
Yes, you can see that here we have cos alpha x. So that means here it is the formula. What is the inverse Fourier cosine transform formula? Inverse Fourier cosine transform formula. What will you write? F of x is equal to 2 by pi integration from 0 to infinity. It is f of s into cos sx ds, right? So instead of s here, which is the parameter used? You can check out from this. Here it is cos sx, but here it is cos alpha x. So that means instead of s, the parameter used is lambda. And here you can see the answer, the RHS is in terms of alpha. That means this is our f of alpha, I'll write instead of s. This is our f of alpha. So if you put this formula in terms of alpha, it is 2 by pi integration from 0 to infinity f of alpha. That is f of the Fourier transform of the Fourier sine transform of the function into we have cos alpha x d alpha. So this is the formula. Now what is f of alpha now? Write it. Given f of alpha is equal to the RHS here. F of alpha, it is e raised to minus alpha x. Okay, substitute it. 2 by pi integration from 0 to infinity. F of alpha is e raised to minus alpha x into we have cos alpha x d alpha. Now evaluate this integral with respect to alpha. How to integrate this? Two by pi. Apply your formula. Integration of e raised to ax into cos bx dx. It is e raised to ax divided by a square plus b square, a cos bx plus b sin bx. So this is the formula. E raised to minus alpha x divided by what it is. What will be your a square plus b square? What is a?
Alpha square, ma'am.
Alpha square. You are integrating with respect to alpha.
Minus x, ma'am.
Yes, integration is done with respect to alpha here. So a means it is coefficient of alpha now. Here you are integrating with respect to x. So we have taken the coefficient of x as in the denominator. Now here it is, you are integrating with respect to alpha. So the coefficient alpha is minus x. Minus x whole square means you'll be getting it as x square. And again here, the coefficient of alpha it is
X, ma'am.
x. So we can write, did I do any mistake? Wait. 1 second. Question I wrote wrongly. It is e raised to this. This is ax here. Make a correction. Given RHS, this is e raised to minus ax. Make this correction. It is not alpha. It is e raised to minus ax. So your f of alpha is e raised to minus ax. F of alpha, it is e raised to minus ax. Wherever you have written e raised to term, that should be e raised to minus ax. So here you have e raised to minus ax. Not ax, it is again, I'm writing wrong. Wait. It is e raised to a alpha. What is it? Should not be in terms of x, you know. Answer should be in terms, what should be the answer in terms of whenever you write Fourier sine transform or cosine transform or whatever, your answer will be in terms of f of s. That means you should not have any x in your RHS. It is e raised to minus a alpha. Make a correction. E raised to minus a alpha it is. Okay. E raised to minus a alpha cos alpha x d alpha. Now coefficient of alpha is minus a. So minus a whole square, we just write it as a square. Then coefficient of alpha in cosine term, it is x square. Then a means here it is minus alpha, sorry, minus a, right? A means here it is minus a into, we have cos alpha x plus b means here it is x sin alpha x. Limits are from 0 to infinity. Limits are from 0 to infinity. Substitute the limits. 2 by pi. Limits, if you put infinity, e raised to minus infinity, it is 0. If you put 0, 1 divided by a square plus x square into, we have minus a, and cos 0 is 1, sin 0 is 0. So we have the answer 2 by pi into a square plus x square. Okay, I left minus a is there, 2, a it is a divided by a square plus x square. So it is 2a divided by pi into a square plus x square. So that is our function f of x. Let us go for another example. Find the inverse Fourier transform of find the inverse Fourier transform of e raised to minus u square. E raised to minus u square. What you have to write the formula? What's the formula? What formula you have to apply? Anybody?
Inverse Fourier transform.
Yes. Inverse. See, it is just inverse Fourier transform. No sine, no cosine. Okay. It is just applying the inverse Fourier transform. The inverse Fourier transform is given by what's the formula?
F of x equal to 1 by 2 pi integration of minus infinity to
Yes.
plus f of x e raised to minus I x dx.
Yes. See the limits here. Here it is minus infinity to plus infinity, and what will you write? F of s into e raised to minus I x ds, right? So applying inverse Fourier transform, or it is also called as, I don't know whether I told you or not, it is also called as the complex form of Fourier transform. If they mention, find the complex form of Fourier transform, because you have I here, it is also called as the complex Fourier transform. Okay. So Fourier transform or complex form of Fourier transform, both are same. Now, what is the parameter used instead of s? We find the inverse Fourier transform of this function. So that means given function, instead of f of s, it is f of u here. So the parameter used is u. Shall I write in terms of s or in terms of u? Which parameter shall I take? Are you comfortable with u?
Yes, only, ma'am.
Yes only means you have to write it as 1 by 2 pi. Write it here. Let f of s is equal to e raised to minus s square. You have to write that. Let us write it as e raised to minus s square. Then integration from minus infinity to plus infinity, e raised to minus s square, e raised to minus isx ds. Evaluate this integral. How to evaluate this integral? 1 by 2 pi integration from minus infinity to plus infinity. Bases are same. We'll add the parameters. S square. Let me keep minus also outside. Plus isx ds. It is. How to integrate this? In the given form, it cannot be integrated. What should be done? What should be done? I wonder whether you had prepared for your IA or not. I'll send a photo of this, such an example similar to this. Okay, let it be. This cannot be integrated. So what you have to do is write it as a whole square term. Try to write this as a whole square term. So for that, coefficient of x is is, half of it is is by 2, square of it is I square s square divided by 4. Add and subtract this term to this so that we can write it as a complete square. I square s square by 4 minus I square s square by 4 integrated with respect to s. We'll add and subtract. Square of half the coefficient of x. So half the coefficient of x means it is is by 2. Its square. It is I square s square divided by 4. Now 1 by 2 pi e power, or shall I write it inside first, e integration from minus infinity to plus infinity, e raised to minus this whole term, this term can be written as s plus is by 2 whole square. We can write it as s plus is divided by 2 whole square, and this term, it is minus of minus, it becomes plus. I square is minus 1, so again minus, I'll just write minus here instead of writing minus 1, minus s square by 4. It is to be integrated with respect to s. I'll write it as 1 by 2 pi. This term, it is like e raised to a plus b. Let me bring this term, e raised to b term, outside because it has, what mistake did we do? Can anybody tell? What's the mistake we have done? Anybody can tell? Suppose the equation is x square plus 2x. What will you add and subtract to this so that it becomes a complete square? I'll make it one, wait, I'll write it is ax. What will be added and subtracted for this?
Squaring and divided by half of it.
Which term? Can you tell me? What the term should be?
Coefficient of
AM.
Coefficient of
a,
x means
ma'am.
yes, it is a by 2 whole square, right? We have to do this. And here we are integrating with respect to s. We are integrating with respect to s. That means s is our parameter. S is our, instead of x, we have here s. Now leave this x. What's the coefficient of s here? What's the coefficient of ix? It is, yes. Okay, hope you are understanding it. Coefficient of s is ix. Half of it, then square of it. It is I square x square divided by 2. Not s square, it should be x square. Because the variable with which you are integrating is s here. Okay, now ix by 2, and here it is x square by 2. Okay, hope I written correctly now. Now this term is independent of s. We can keep it outside the integral sign. E raised to minus of minus, it becomes plus x square by 4. Integration from minus infinity to plus infinity, e raised to minus of s plus ix by 2 whole square ds. Now, how to integrate this? How to integrate this? Nobody has seen that example, I think. Now what we do is
Apply log e raised to log e.
Log. How will you get log? No, log you can't write. 2 times integration from 0 to infinity, e raised to minus x square, x raised to 2n minus 1 dx. It is gamma n. Integration from 2 times 0 to infinity, e raised to minus x square, x raised to 2n minus 1 dx. This function is written as gamma of n. Well, try to write this in that form. E raised to minus, we have some term here, this term we have. So let us substitute it as t. So for that sake, put s minus ix by 2 is equal to t. So what is your ds is equal to dt. No change there will be, even in the limits, as s tends to minus infinity, t also tends to minus infinity, and as s tends to plus infinity, your t also tends to infinity. So the function becomes 1 by 2 pi e raised to x square by 4 integration from minus infinity to plus infinity e raised to minus, it becomes t square. The bracket term is substituted as t, so it is minus t square, and ds becomes dt. Now we'll compare with this. We'll compare with this integral. Now here the limits are from 0 to infinity, whereas our limits are from minus infinity to plus infinity. How to change the limits? E raised to x square by 4. How to change the limits? Instead of minus infinity to plus infinity, I want 0 to infinity. Is it not an even function? E raised to minus t square. E raised to minus t square. It's an even function. Limits are like minus a to plus a. So by using the property of definite integrals, we'll write it as 2 times 0 to infinity e raised to minus t square dt. Okay. Now it is in this form, but this term is missing. X raised to 2n minus 1 is not there. That is t raised to 2n minus 1. That implies this term has to be 1. We want x raised to 2n minus 1 term is 1. This implies 2n minus 1 must be equal to 0. If this power is 0, anything raised to 0 is 1. So we'll equate this 2n minus 1 equal to 0. This implies n is 1 by 2. This implies n is 1 by 2. So what I want to say in all is, if you have this function, gamma function, compare the terms. Here you have e raised to minus t square, here it is e raised to minus x square. Now this term x raised to 2n minus 1 is not there. That implies 2n minus 1 must be equal to 0, and thus n is 1 by 2. If n is 1 by 2 means you will be getting this integral, that is only integration from 0 to infinity, 2 times of course, 2 times integration from 0 to infinity e raised to minus x square dx is nothing but the gamma 1 by 2. It is gamma 1 by 2. So we'll write this function as 1 by 2 pi e raised to x square by 4. The whole this integral including 2 is gamma 1 by 2. It is gamma 1 by 2. Value of gamma 1 by 2?
Root pi.
Root pi. So I'll write it as root of pi. So pi cancels that. Root pi can get cancelled. It becomes e raised to x square by 4 divided by 2 root pi. So that is your answer. F of x is equal to f of x. Remember this gamma function definition. It is used many times. In Laplace transform you use it, in Fourier transform you use it. Let me go for one more example.
Ma'am, it is e raised to minus x square by 4.
Minus is that? No, minus of minus has it has become plus. I'll show you. Here it is. This term, no? This term. See here outside you have a minus. I'm talking about this term. This here. Okay. Here you have minus outside. This minus is there outside. It is multiplied to this minus. It has become plus.
Then I square is equal to minus 1.
Okay, right. Write it minus there. Then everywhere you have to write minus. Bring minus outside. It is minus x square. Everywhere you write the answer as e raised to minus x square. Okay, thank you. It is e raised to minus x square by 4 under root 2 by 5. Okay, take another example. Solve the integral equation. Solve the integral equation. The variables are different here. See that you will be taking the values correctly. Integration from 0 to infinity. F of theta cos alpha theta d theta is equal to 1 minus alpha for 0 less than or equal to alpha less than or equal to 1, and it is less than 1. Hence evaluate integration from 0 to infinity sin square t by t square dt. Hence evaluate
Hello, ma'am.
integration from 0 to infinity. Yes.
No,
Did you say
nothing, ma'am.
anything? Anybody?
Sorry.
How to take this? How will you write? Check the variables. First understand the variables. Here it is f of theta cos alpha theta. Answer is in terms of alpha. What will you write the LHSs? What will you write the RHSs? First decide that. Then see that we'll write the terms correctly. When will you get this? Integration from 0 to infinity f of theta cos alpha theta d theta. Which transform is it?
Fourier cosine transform.
Yes, because you have cos alpha theta, it is the Fourier cosine transform. What's the formula? Usually, now don't write this. Usually, what will you write? The Fourier cosine transform of a function. You'll write f of s is equal to
F of s.
Okay.
0 to infinity.
F of s. Integration from 0 to infinity.
F of x.
F of x cos esx dx. If you write this, you'll come to know what the variable is. Instead of x, what is taken?
Theta, ma'am.
Theta.
Theta. Okay, function instead of f of x, it is here f of theta. That means the variable x is taken as a theta here. Again, what about the RHS term? Usually this is our f of s. F of s it is. That means instead of s, the variable taken is alpha. Answer is in terms of alpha. That means instead of s, the variable is alpha. Now solve the integral equation. Solve means you have to find f of theta. But for that, what will you apply?
Inverse Fourier transform.
Yes. You have to go for applying the inverse Fourier cosine transform. Inverse Fourier cosine transform. What's the formula? Can you tell me the formula? In terms of the variables that are given in the example, what will you write? Usually, shall I write it also? I'll write it up here.
0 to
Usually, you will write f of x is equal to, you will write 2 by pi, right? 2 by pi integration from 0 to infinity. You will have f of s or fc of s into cos sx ds. This is what you will be writing usually, this formula. Now what will you write? in terms of the given variables, what it should be. F of x
2 by
means
5.
here we are taken it as f of theta, right? We'll write f of theta equal to, then 2 by 5, integration from 0 to
0 to
infinity,
infinity.
fc of s. Instead of that, what you have to
F
write?
of
F of
alpha.
alpha.
F of
Alpha.
alpha. Yes, it is f of alpha. Then cos,
Cos
what you have to write?
alpha theta.
Cos, yes, see that you'll be writing that correctly. Cos alpha theta. Integration is done with respect to
D
s
alpha.
here, or s is alpha. So it is d alpha. So write this expression correctly and see that substitute your f of alpha and evaluate what is f of alpha. What is f of alpha? Given from the given function where f of alpha, this is our answer, f of alpha. It is minus 1 minus alpha for 0 less than or equal to alpha, 0 less than or equal to alpha less than or equal to 1, and it is 0 for alpha greater than 1. Right? Now how to split this integration? Therefore 2 by 5, integration from 0 to 1 and again from 1 to infinity. In the interval 0 to 1, f of alpha is 1 minus alpha. F of alpha is 1 minus alpha into, we have cos alpha theta. We'll write it as it is, cos alpha theta d alpha. Second integral, it is 0. Now try to evaluate this integral. Two by pi. Apply Bernoulli's rule. 1 minus alpha as it is. Integration of cos alpha theta. What's the integration? Sin alpha theta divided by
Alpha, ma'am.
You are integrating with respect to alpha.
Theta, ma'am.
Theta should be, yes. See that you'll write the variables correctly. Minus derivative of 1 minus alpha, it is minus 1 because you are differentiating with respect to alpha again. Integration of sin alpha theta by theta is minus cos alpha theta divided by theta square. Limits are from 1 to 0 to 1, is it? Limits are from 0 to 1. Substitute them now. 2 by pi. If you put 1, 1 minus alpha becomes 0, the first term. If you put 0, sin 0 becomes 0. So totally first term reduces to 0. Now we have minus here. Let me keep minus outside because 3 times it is minus. So we'll be getting minus. Let us keep minus outside the term. Now we have cos alpha theta and even theta square can be kept outside. For alpha, you are substituting the values. So it becomes cos theta minus cos 0, it is 1. Alpha is substituted as 1, so it becomes cos theta. If you put 0, cos 0, it is 1. So your answer is 2 into 1 minus cos theta divided by theta square pi. Now this is our f of theta. Solve the integral equation it is. So we have obtained the value of the function. Now again it is hence evaluate. Hence evaluate sin square theta by theta. Theta square is there, is it? Or sin square t by t square. So for that, let us write this in terms of sin. 1 minus cos theta can be written as 2 sin square theta by 2 divided by, we have theta square pi. So we can write it as 4 times sin square theta by 2 divided by pi into theta square. Now for hence evaluate, what will you do? This is the solution for we have solved the Fourier whatever the equation that was given, and by that we have obtained f of theta. So now what it is, we have to obtain the integration from 0 to infinity sin square t by t square. For that we apply inverse Fourier cosine transform. Apply inverse Fourier cosine transform. So what we get? What's the formula?
Y inverse Fourier cosine transform.
Whatever we have obtained is f of x right now. Is it right?
Yes, ma'am.
Theta is x, no? I'm only getting confused. Lots of variables. Yes. X, no, we have got. What we have got is f of x. This is our f of x. Okay. This is our f of x. We have got. What we want is integration of sin square t by t square. What will you write the inverse Fourier transform? I'll just write the formula, I'll come to know. Instead of yes, it is alpha. What is f of alpha equal to? 2 by pi integration from 0 to infinity. We'll write f of
theta.
Theta cos
Alpha theta.
alpha theta d alpha. Is it right? We have to apply this. What is asked today? See where it is. Hence evaluate. Hence evaluate. It is 0 to infinity sin square t by t square. Now we want this integral. We want this integral. When will you get this integral? If you substitute that answer, what is the answer? You have got f of theta. This answer, it is in terms of sin square t by t square. That is just you can replace that theta by t. You will be getting sin square t by t square. If you put that f of t here, you will be getting integration of that. Later we have to think of what values should be substituted so that this becomes 1 there, and we will be evaluating that out. Okay. So we'll be taking this now. What is f of alpha? You know the value of f of alpha? It is 1 minus alpha. Where it is? Yes, f of alpha is 1 minus alpha for the interval 0 to 1. Now that we will be substituting later. Now let us put the value of f of theta here. It is 4 sin square theta by 2 divided by pi theta square into we have cos alpha theta d alpha. Now, can you tell me what you have to do? This term should vanish.
Madam, it is Fourier cosine transform or inverse Fourier cosine transform? F of theta equal to, then it will be inverse, no?
Yes, yes. It is just Fourier transform, no?
Yes, ma'am.
Yes, yes, sorry. It is Fourier transform, not inverse.
Then it will be integrated with respect to d theta, no?
Yes, integration should be done with respect to theta then. If it is Fourier transform, integration is done with respect to theta. Yes, it is d theta. Okay. Now what should be substituted for alpha so that this term goes off?
0.
Yes. Put alpha equal to 0 so that cos 0 is 1. Okay. So this implies cos alpha theta is 1. And what is f of alpha? For alpha equal to 0, what is f of alpha? Where is the function? Here it is. Alpha equal to 0 if you put here. F of alpha, that is f of 0 means in the interval, it is here 0 less than or equal to alpha less than or equal to 1. So if alpha is 0, we will be taking the function 1 minus alpha. That means it becomes 1, right? F of alpha is equal to 1, and that is for alpha equal to 0. Okay. Now substitute it. 1 equal to 2 by pi integration from 0 to infinity. We have 4 sine square theta by 2 divided by pi theta square, and we have cos alpha theta is now 1 into d theta. Okay, so transferring these constants to the other side, we can write pi square by 2. This pi into pi, this pi square, 2 I have taken on the other side, is equal to integration from 0 to infinity. It is sine square theta by 2 divided by, I can write theta square by 4. This 4 I have taken to the denominator. It is theta square by 4. Now if you put theta by 2 is equal to t, then d theta is equal to 2 dt. So substituting that value, integration from 0 to infinity, sine square t divided by t square d theta is 2 dt. So if you bring this 2 to the other side, what will you have?
Pi square by 4.
Pi square. Answer I have written pi by 2. Where did I make mistake? I have written correctly. Did we do any mistake?
From that 4 to the 8 number?
Yes.
In the third step, second.
Which one?
Last third step.
This one.
Yes, ma'am.
What happened?
4 to the 8 number. 4 sine square theta by 2.
4 I kept here only. What I did is I have taken that 4 to the denominator. I have taken this 4 to the denominator.
Okay, ma'am.
Okay. Mistake what you have done is we did not correct this. Wait. We wrote Fourier cosine transform. Then constant will not be there, no? Is it not? I had written inverse, so I had taken this 2 by 5. So this 2 by 5 will not be there. Is it so?
Yes, ma'am.
2 by 5 will not be there because we are taking only Fourier cosine transform. 2 by 5 is not there. That means what this term becomes, this pi is taken on the other side, it becomes pi is equal to, right? This is pi. Even only pi is there. Now we'll bring this 2 to the other side. We'll get the answer. It is pi divided by 2 is equal to integration from 0 to infinity. It is sine square t by t square. That is our answer. In time like you have class. Classes are going on other subjects.
Yes, ma'am.
Okay. And I think this completes your Fourier transforms. If you have any doubts, you can ask me. Otherwise, tomorrow we'll begin Z transform.
Okay.
Is it okay if I begin Z transform tomorrow? Your, I think last working day has extended up till February. No, up to February you have lots of time. If you want, or else I will send some homework examples. Try them. If you have any doubts, you can ask me tomorrow. We'll solve them. Okay. Or else I'll begin with the Z transform.
Ma'am, take another one class on this different variables.
Yes. That's what I told. If you try, it will be better. If you want, I can take. If you want, I'll take one more class on this.
Yes, ma'am.
Okay. Tomorrow again, we'll have some more examples on this. Later, next Wednesday, is it holiday? No. Okay. Wednesday, we'll go for that answer. Okay. If you tried any example, you have not got them, then you send me that question so that I can solve it tomorrow. Otherwise, I'll take any other examples. But send me today itself. If you have not got any examples from the textbook or anywhere, send me those examples today itself so that I can solve them tomorrow. Or else I'll take some other examples.
Okay.
Okay.